Hi students, in this video we're going to start to learn about logarithms. Alright, so after watching this video you should be able to explain what a logarithm is, both mathematically with equations and also with words. Understand that logarithms are the inverse of exponentials or the opposite of exponentials in the same way that addition and subtraction are sort of opposites and inverses. And finally, solve simple logarithmic equations both with and without technology. Alright, so something to remember. So exponential or indicial equations look like the following. 2 to the x equals 8, where 2 is the base, x is the power or the index or exponent, any of those words you can use to describe x, and then 8 is the value of that expression. Alright, so an introduction to logarithms. So logarithms are the inverse operation to exponentials. So just like in the same way add and subtract are inverse operations to each other, and squared and square root are inverse operations to each other, in the same way logarithms are the inverse operation to exponentials. Now logarithms are used in a variety of ways. Logarithmic scales are used to measure earthquake size. So the Richter scale uses logarithms to measure and compare earthquake sizes. Logarithmic scales are also used to measure pH and acidity of chemical substances as well. Now, when evaluating an exponential, we are interested in calculating the value. Okay, so the value we get at the end of our expression, that's what we're looking for when we're trying to calculate exponentials and exponential equations. Now, a question involving exponentials would be, what is the value of 2 cubed? So if x equals 2 cubed, then the value of x is 8. Right? So that's our standard exponential equation. Instead of calculating the value, logarithms are used to calculate the power. So we're not after this value anymore. We are now, with logarithms, thinking about what is the power. Now, a question involving logarithms would be 2 to what power equals 8? Okay, so that's the equation we're looking to solve then with a logarithm. Right? What is this power of 2 that gives us 8? Right, so in general, if a to the x equals y, then we can also say that log base a for the value y gives us x. So writing that out, so if we can say a to the x equals y, then we can also say that log base a of y is equal to x. So basically we're just rearranging that equation to get y on its own on the left hand side, or x on its own. We're basically just rearranging those sorts of equations, which is why we can say that logarithms are the opposites of exponentials, the inverse operations, as you will. So the first equation here can be stated in English as a to the power of x equals y, and that's one we're familiar with. The second one, the new statement, can be stated as the logarithm of y with base a is equal to x. So saying the same thing, but we're looking for different outputs. So in the first one, we're saying the output is the value y. For logarithms, the output is the power of a that we need to give us y. Now note, students, on your calculator there is a log button. Now that log uses a base or an a value of 10. So for example, if we've got log of 100, okay, so log, there's nothing written there, we assume that's base 10. Right? And our calculator assumes that's base 10. So what this value will give us is what power of 10 gives us 100, and we should see that answer is 2. 10 to the 2 gives us 100. Alright, so let's write some equivalent statements for the following. So basically change them from exponential form to log form. or the other way round. So we've got 7 to the 3 equals 343. So we've got our base is 7, our power or our exponent is 3, and our value is y. So rewriting that, we can say log base 7 of 343. So we've got our a value and our y value together now with our log equals 3. So we're saying is 7 to what power gives us 343? Well, that's 3. 3 is the logarithm of 343 base 7. Now rewriting this one, here we've got our base. So our base is a, our power is 4, so 3 to the 4 equals our value y, 81. And that's how we use logs and exponentials to rewrite equations. Alright, let's calculate the following logarithms without a calculator. So we've got log base 2 of 16. So remember, we're reading this as 2 to what power gives us 16? Well, we know 16 equals 2 to the 4, so therefore, what power of 2 gives us 16? Well, it's this 4 value here. So log 2, 16, what power of 2 gives us 16? It is 4. Right, in our second problem, okay, we've got log base 10, 0.001. Now, rewriting that one, 0.001 equals 1 over 1,000. Right, so we've got tenths, hundredths, thousandths. And so we can write that as 1 over 10 cubed, or 10 to the negative 3. So what that means then is log base 10 of 0.001, right? 10 to what power gives us 0.01? 001. There's our power, negative 3. And that's how we can calculate logarithms without a calculator, just by realizing that we're using our index laws and working out what power of our base gives us the value that we're given. Now, just using a calculator, we can type in that one. So log 12, typed into the calculator, you should get 1.08. Again, just press log 12 equals, there's how we calculate logs using a calculator. Right, our final examples, let's determine the value of x in the following equations. So we've got here 2 to what power gives us 32. All right, well that's alright, 1, 2. So 32 equals 2 to the power of 5. So when we get to our logarithm, log 2 base 32. So 2 to what power gives us 32? Well, we just worked it out. No, it was our power 5. This one here, we've got 3 to the, log base 3 of x equals negative 3. Now let's rewrite that one. So we've got a base of 3, a power of negative 3, and that should equal x. So rearranging that one, that's 1 over 3 to the 3 equals x. 3 to the 3 is 27. So x equals 1 on 27. And that's how we can solve a different sort of logarithmic equation, where instead we have to work out the value. And we can do that just by rewriting our equation. Alright, so after watching this video, students, you should be able to explain what a logarithm is. You should understand logarithms as the inverse, the opposite operation to exponentials, and then you should be able to solve some simple logarithmic equations both with and without technology.